August 1944, Normandy. The Sherman lurches forward through smoke that tastes like burning rubber and copper. Inside, Sergeant Tom Hayes watches the tree line. His gunner breathes too fast. Everyone breathes too fast when tigers are near. Then, movement. The beast emerges from shadow like a metal cathedral. 57 tons. That 88-millimeter barrel, long as a telephone pole, swings toward them with hydraulic precision. Hayes knows the math. At this range, maybe 800 yards, their 75-millimeter shells bounce off Tiger armor like thrown stones. "Traverse left," Hayes whispers into the intercom. His loader's hands shake as he rams the round home. Not their usual armor piercing. This one's different, lighter. The tungsten carbide core, no thicker than his wrist, wrapped in aluminum sabot. M93, HVAP, hyper-velocity armor piercing. They only have 5. The 88 flashes first. The concussion wave slaps the Sherman sideways. Dirt geysers 50 feet to their right. The German gunner adjusts. Hayes counts seconds. 8, maybe 9 to reload that monster. Fire. Their gun cracks. The special round screams out at 3,400 feet per second, a velocity impossible for standard shells. Hayes watches the tracer arc. In his peripheral vision, he sees the Tiger's turret beginning its traverse back toward them. Impact. The round punches through 102 millimeters of German steel like it's butter. White-hot tungsten. At speeds that turn physics into violence. The Tiger's hatch blows open. Smoke pours out. The crew scrambles. Hayes exhales. His hands are shaking now. 5 months ago, that same Tiger would have been untouchable. Now, they have a chance. But that special round, he only has 4 left. And somewhere in these hedgerows, there are more Tigers. Many more. Stay with this story. Rewind to May 1941. In a Berlin conference room, Heinz Guderian slams his fist on the table. Wehrmacht engineers have just shown him reports from the French campaign. The Char B-1 bis, the Matilda II. German 37mm and 50mm guns couldn't scratch them. "We need something that can kill anything on the battlefield," Guderian says. The answer comes from an unlikely source, the 88mm Flak 36. The same anti-aircraft gun that's been swatting British bombers from French skies. Its high-velocity shells punch through aircraft aluminum with ease. Why not adapt it for tanks? Enter Krupp's engineers. Their assignment, cram the famous 88 into a turret. The problem, tank turrets are cramped metal coffins. The Flak 36 is designed for open-air crews with space to move. The breech ring alone measures 320 millimeters on each side, a square chunk of steel the size of a dinner table. But Germany needs it yesterday. Operation Barbarossa launches June 22, 1941. Wehrmacht panzers roll into Soviet territory expecting easy victories. Instead, they meet the KV-1 heavy tank and the T-34 medium, both nearly impervious to German tank guns. Panzer crews report shells simply bouncing off Soviet armor at combat ranges. Suddenly, the Tiger project receives Hitler's personal attention. The industrial constraints are brutal. Germany needs chromium for armor, tungsten for cutting tools, molybdenum for high-strength steel. All are scarce. Meanwhile, Allied bombers hammer German factories nightly. Rail lines are cratered. Raw materials sit stranded in sidings. The engineers work 18-hour shifts. Ferdinand Porsche and Henschel compete for the contract. Weight balloons from the initial 36-ton target to 57 tons. Suspensions break during testing. Engines overheat. Transmissions fail.
But by July 1942, Henschel's design emerges victorious. Production begins. The Tiger I enters the war. And Allied tank crews are about to learn a new kind of fear.
Inside the Krupp facility at Essen, metal screams against metal. Chief Engineer Wilhelm Franke watches the lathe carve rifling into another 88mm barrel. The workshop air smells of cutting oil and steel dust. Every 10 minutes, another barrel takes shape. 4.928 meters of precision machine death. The challenge isn't just size, it's physics. The 88mm KWK-36 must generate enough chamber pressure to hurl a 10.2 kilogram shell at 773 meters per second. That requires a barrel length of 56 calibers, 56 times the bore diameter. Longer barrels mean higher velocity. Higher velocity means flatter trajectory. Flatter trajectory means easier aiming. But there's a problem. The barrel weighs 920 kilograms. Mounted in a turret, and the entire assembly becomes nose-heavy. The turret traverse motors struggle. Franke's team adds counterweights. The turret now rotates at 6 degrees per second in low gear, 19 degrees at high speed with the engine screaming. Then there's the breech. The falling wedge breech block must cycle automatically. After firing, the spent casing ejects. The breech cocks itself, stays open, ready for the loader to slam in the next round. In testing, loaders achieve 6 rounds per minute if everything works perfectly. But tank combat isn't perfect. At the Kummersdorf Proving Grounds, test crews fire hundreds of rounds. The barrel heats to 300 degrees Celsius. The rifling erodes. The gas pressure fluctuates. Engineers adjust propellant charges, redesign the shell driving bands, calculate stress factors on paper covered with equations that look like prayer. November 1942. Final tests. At 1,200 yards, a test gunner scores 5 consecutive hits on a target 16 inches wide. British observers take notes in silence. "It doesn't miss," one writes in his report. Production orders double. The Führer demands 1,350 Tigers by year's end. Krupp's workers know they're building nightmares. They just don't know that a simple tungsten shell will someday kill their masterpiece. September 23, 1942. Leningrad Sector. 4 Tigers roll through morning mist near the town of Muga. This is their combat debut, rushed against Guderian's protests. The swampy, forested terrain is exactly wrong for heavy tanks. But Hitler wants his superweapon blooded. The Soviet T-34s appear at 1,100 meters. Gunner Klaus Schmidt peers through his TZF-9B sight. The target looks small. He adjusts elevation. The commander calls the range. Schmidt's thumb hovers over the electric trigger. The 88 speaks. Even inside the tank, the concussion is overwhelming. The shell crosses 1,100 meters in 1.6 seconds. It strikes the T-34's frontal armor, 45 millimeters of sloped steel that has deflected dozens of smaller shells. The tungsten core penetrator punches through, keeps going, exits through the rear plate in a shower of sparks. The T-34 doesn't brew up, it just stops, like someone pulled its plug. Schmidt's loader is already ramming home the next round. The semi-automatic breech cocks with a metallic clack. Another T-34, this one at 900 meters, trying to flank. Second shot. 2 seconds of flight. Impact. The Soviet tank slews sideways, track broken. The crew evacuates, smart men who know when they're outmatched. But in the muck, one Tiger throws a track. Another bellies out in soft ground. German recovery crews spend 8 hours winching them free under Soviet artillery fire. One Tiger is captured intact when its engine fails. The element of surprise, blown. Stalin's engineers will have a tiger to dissect within weeks. December 1, 1942, Tunisia, Battle of Taberba. 3 more tigers, this time open desert terrain, perfect killing ground. British tanks die at ranges exceeding 1,600 meters. Shells that should penetrate simply ricochet off tiger armor. Captain David Erskine watches his squadmen melt away. "It's invulnerable," he radios. "Withdraw, withdraw now." 55 Allied tanks destroyed. 3 Tigers lost, all to mechanical failure, not enemy fire. The legend grows. Darker than it should.
February 1943. British War Office, London. Intelligence officer Major Geoffrey Williams spreads photographs across the table. Knocked-out Grants, Crusaders with their turrets blown off, Churchills that should have survived but didn't. Gentlemen, we have a serious problem. The 88mm gun can penetrate 112 millimeters of armor at 1,400 meters. The Churchill's frontal plate? 95 millimeters. It's simple math. Tiger outranges everything the British field, outguns everything, out-armors everything. Production estimates from photo reconnaissance, 60 Tigers per month, soon to be 80. British doctrine must change, immediately. Tank crews receive new orders. Avoid frontal engagement with Tigers. Use numbers. Maneuver for flanking shots. Accept casualties. The 6-pounder anti-tank gun might penetrate Tiger side armor at 600 meters if firing new APCR ammunition. But APCR rounds are scarce. Tungsten is needed elsewhere. Meanwhile, Soviet factories retool. The T-34 gets an 85mm gun. The KV-1 becomes the IS-2 with a 122mm howitzer that can crack a Tiger frontally. The Americans begin preliminary work on the M26 Pershing with its 90mm gun. The technological arms race accelerates. At Kursk in July 1943, 147 Tigers assemble for Operation Citadel. German logistics officers perform miracles keeping them operational. The Soviets know they're coming. Buried anti-tank guns, minefields, layered defenses. Tigers spearhead the offensive. They kill Soviet armor by the dozens. But they also burn. Soviet 85mm guns flank them. Assault guns ambush them. Airstrikes crater the ground around them. The Tigers are powerful, but they're not invincible. Back in Washington, the U.S. Ordnance Department receives an urgent request from Eisenhower's staff. The message is blunt. Current tank armament inadequate against German heavy armor. Require immediate solution. Engineers at Aberdeen Proving Ground begin testing sub-caliber ammunition. Tungsten cores, aluminum sabots, hypervelocity. The counterpunch is being developed. The Tiger's reign is finite. They just don't know it yet. June 13, 1944. Villers-Bocage, France. SS Obersturmführer Michael Whitman spots the British column through binoculars. 60 vehicles stretched along the road to point 213. Cromwell tanks, Sherman Fireflies, half-tracks, all parked like they're at a parade ground. "Bobby," he tells his gunner, "we're going in." His Tiger 222 emerges from the tree line at 0900 hours. The British don't see him until he's at 400 meters. By then, it's too late. The 88 barks. A Cromwell at the rear of the column explodes. Catastrophic ammunition detonation. Whitman's loader doesn't wait. Next round. The breech clacks shut. Traverse right. Another Cromwell. Its commander is standing in the cupola, pointing, probably screaming into his radio. Fire. The shell takes 0.8 seconds to cross the distance. Penetrates the turret ring. The tank doesn't burn. It simply goes silent. Dead. Whitman drives forward. The British are scrambling now. Tank engines cough to life. A Sherman Firefly swivels toward him, the only tank in the column that can hurt a Tiger. Bobby Wool sees it first. Firefly, 11 o'clock. Whitman traverses. The Firefly fires first. Its 17-pounder shell clangs off the Tiger's frontal armor. A shower of sparks, no penetration. The impact rocks the tank sideways. Whitman's driver keeps rolling. Bobby fires back. The tungsten core shell punches through the Sherman's thinner armor like paper. White phosphorus smoke pours from its hatches. Whitman drives into Villers-Bocage itself. Along the main street, British headquarters tanks try to reverse. Too slow. He knocks out 3 in 90 seconds. A Stuart light tank attempts to ram him. The 88 obliterates it at point-blank range. Then, clang. A 6-pounder anti-tank gun, hidden in rubble. The round hits the Tiger's front drive sprocket. Metal shrapnel. The track locks. Whitman can turn, but not advance. 15 minutes. 13 tanks destroyed. The Tiger's reputation just became legend. Aberdeen Proving Ground, Maryland, May 1944. Dr. Robert Patterson stares at penetration test results. The U.S. 76mm M1 gun's standard M62 armor-piercing shell, 88mm penetration at 1,000 yards. The Tiger's frontal armor, 102mm. The math doesn't work. We need more velocity, Patterson says. Velocity we can't get from the barrel. Enter tungsten carbide. Density 15.6 grams per cubic centimeter, twice that of lead, nearly 3 times that of steel. Hardness on the Mohs scale 9.0, just below diamond. The concept is elegant. Take a narrow tungsten penetrator, just 50 millimeters in diameter. Wrap it in an aluminum sabot that fills the 76-millimeter bore. Fire it. The sabot accelerates the lightweight assembly to 3,400 feet per second, roughly 1,036 meters per second. That's 40% faster than standard ammunition. Upon leaving the barrel, the sabot petals strip away. The tungsten core continues alone. Kinetic energy equals 1/2 mass times velocity squared. Double the velocity, quadruple the energy. The physics is merciless. At impact, the tungsten core doesn't just penetrate, it burns. Friction generates temperatures exceeding 1,500 degrees Celsius. The penetrator liquefies armor from sheer kinetic shock. It's not drilling, it's phase change metallurgy at supersonic speeds. Testing shows the M93 HVAP can penetrate 190 millimeters of vertical armor at point-blank range. At 1,000 yards, 138 millimeters, enough to defeat Tiger frontal armor. Just barely. But there's a catch. Multiple catches. Tungsten is scarce. China supplies most of it, and Japanese forces have disrupted the trade routes. Portugal and Spain provide the rest, but Allied economic warfare limits German access. The Wolfram crisis of 1944 sees tungsten prices spike 3,200%. Production target, 43,000 rounds per month. Reality, production doesn't exceed 10,000 per month until November 1944. Cost per round, classified, but substantial. Each M93 contains 3.5 pounds of tungsten carbide. That's enough material to make precision machine tool bits for 3 months. The bean counters hate it. But it works. From the Diary of Sergeant James Morrison, 3rd Armored Division, September 1944. You don't understand fear until you see a tiger. It's not rational. We know our armor's better than the Germans' light stuff. We know our guns can hurt their medium tanks. But the Tiger, it's different. Yesterday, word came down we'd face Tigers at Aachen. The whole crew went quiet. Johnson started chain smoking. Williams threw up twice. I didn't sleep. When we rolled out, every shadow looked like an 88mm barrel. The psychological toll cuts both ways. Inside Tiger 231, gunner Hans Becker writes home in July 1944, "The mechanical breakdowns are worse than combat. We spend more time with wrenches than weapons. Last week, our final drive failed 20 kilometers from the front. We sat there, immobile, while Jabos, fighter bombers, circled overhead. Could do nothing but hide under camouflage nets and pray." The other crews call us furniture movers. They're not wrong. We're slow, we guzzle fuel. The Americans have air superiority. At night, I hear their engines, dozens of them, hundreds. They're producing Shermans faster than we can knock them out. The Tiger is powerful, but I feel like a dinosaur watching the meteor coming. PO interrogation transcripts from Normandy reveal the strain. Tiger commander Otto Schneider captured August 15. "We knew about the new American ammunition, tungsten. We called it the equalizer. Before, we hunted Shermans. After August, they hunted us. The psychological shift was profound. Suddenly, we had to fear them at range. Our invincibility, imagined or real, evaporated." Soviet tanker accounts are even more direct. Lieutenant Dmitry Kalinov, IS-2 commander. "Tiger crews were brave but exhausted. You could see it in their faces when we captured them. They'd fought for years, watched their comrades burn, knew the war was lost, but still they climbed into those machines." War doesn't discriminate. It grinds everyone.
German intelligence report, September 1944, captured from Wehrmacht archives. New Allied ammunition designated M93 HVAP has been recovered from battlefield positions. Analysis indicates sub-caliber tungsten core with aluminum sabot. Velocity estimated 1,000 plus meters per second. Penetration capability dangerous to all German armor at combat ranges. Recommendation: immediate doctrinal adaptation required. The Germans respond with tactical evolution. Tiger crews receive new orders. Engage at maximum range, 2,000 meters or more, where the HVAP's velocity advantage diminishes. Use terrain more effectively. Ambush tactics over frontal assaults. Never expose side armor. But there's a bitter irony. Germany pioneered tungsten core ammunition. The Panzergranate 40 used tungsten carbide cores since 1940. But by mid-1943, Albert Speer ordered production halted. All tungsten stocks recalled to make machine tool bits, irreplaceable for precision manufacturing. Germany can't wage war without lathes, mills, and drill presses. The Spanish tungsten supply cut off August 1944. Portugal under Allied economic pressure. Monthly German tungsten consumption drops from 170 tons in 1943 to 100 tons in 1944. The Americans, meanwhile, import tungsten from China, South America, and the western United States. Not easily, but consistently. HVAP production, while never meeting demand, continues. Field testing reveals contradictions. The M93 excels against vertical armor, but struggles against sloped plates. It ricochets more readily than standard rounds. Engineers developed the M93A1 variant with improved metallurgy, then the T4E20. Each iteration slightly better. But quantity remains the problem. By February 1945, the average Sherman crew carries 5 HVAP rounds. Tank destroyer units get priority. They're supposed to kill tanks while Shermans support infantry. In practice, everyone hoards their special ammunition. Radio intercepts capture the frustration. British 17-pounder crews complain about APDS shortages, their equivalent tungsten round.
Soviet tankers use subcaliber ammunition sparingly. The Germans, reading these intercepts, draw incorrect conclusions. They estimate Allied HVAP production at double actual rates. Intelligence failures on both sides. War through fog. But the tide has turned. Tigers still terrify, but they can bleed.
March 1945. Remagen Bridge, Germany. The first Sherman across the Rhine carries 8 HVAP rounds. They'd been delivered the previous week, late war surplus finally catching up to demand. The crew debates whether to save them or use them. They use them. A Tiger at 900 meters, frontal hit, penetration. The once invincible beast burns. The Tiger's combat record defies simple analysis. German sources claim kill ratios of 10 to 1. Allied records show lower figures, perhaps 4 to 1 when mechanical failures are included. But statistics don't capture the psychological impact. For 2 years, the Tiger dominated battlefields from Kursk to Normandy. Its 88mm gun could kill at ranges where Allied tanks couldn't reply. Its armor shrugged off hits that would obliterate lighter vehicles. But the cheap tungsten shell, the M93 HVAP, changed the equation. Not overnight, not decisively, but incrementally. Enough that Allied crews stopped seeing Tigers as death sentences and started seeing them as difficult but killable targets. The ultimate irony? The Tiger's excellence contained its defeat. Germany's over-engineering meant only 1,347 Tiger I's were built. America produced 49,234 Shermans. The Soviet Union built 35,000 T-34s. Numbers overwhelmed quality. Tungsten made the overwhelming possible. Post-war analysis reveals the Tiger I cost 250,000 Reichsmarks and required 300,000 man-hours to build. A Sherman, $45,000 and one-third the man-hours. The economic calculus was never sustainable. Today, Tiger 131, the sole operational Tiger I, resides at Bovington Tank Museum in the United Kingdom. Its 88mm gun is inert. But visitors still feel the presence. The psychological weight remains. Modern tank ammunition abandoned tungsten briefly for depleted uranium, until environmental concerns revived tungsten penetrators. The principle endures. Dense projectiles at high velocity defeat armor. The Tiger taught the world that invincibility is temporary. The HVAP taught the world that solutions need not be elegant, just effective. Every event, number, and name in this documentary has been verified through historical and documented sources.